Welcome back to AlgoJS. Today's question is LeetCode 1047, remove all adjacent duplicates in string. So you're given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. So return the final string after all such duplicate removals have been made. It can be proven that the answer is unique. Okay, so in the first example, we have this string. We need to remove all duplicate adjacent values. So we need to remove B and B, which will give us A, C, A. Then we'd have to remove A and A because they'd become a duplicate adjacent pair. And then we're left with CA. And in example 2, we remove X and X, which causes Z and Z to be adjacent to one another and they're duplicates. So we remove that too. And that leaves us with AY. So with this question, it lends itself quite nicely to using a stack data structure because we need to keep track of the previous value. And this is just going to be an auxiliary data structure such as an array. We're going to use last in, first out processing basis, and we're going to run through this and check to see whether the previous value is equal to the current value we're on. And if it is, then we just pop off the stack. If it isn't, we add on to the stack. And finally, we convert the stack back into a string and return that value. So let's run through this first example. We're looping through the string. We check to see the previous value is equal to the current value. There is no previous value in this case. So we just add onto the stack the value of A. We move to the next value. We check to see if B is equal to A. It's not, so we add B into the stack. We move along. We check to see whether B is equal to the previous value, which is B. So what we do here is we pop off the stack. So we remove this value from the stack, and then we are left with A within the stack, and we move along. We check to see whether A is equal to the previous value within the stack. It is. So we pop off the stack, remove that value, and we move along in the string. We add C into the stack because it's not equal to the previous value, and then we add A into the stack. And then we just join this up and return CA as a string. Let's quickly look at the second example. So let's do the same. So let's create a stack. Let's push on the first value. Then we compare the second value to the value in the stack at the previous position. So are they equal? No. So we add Z in there. We move over to X. Is X equal to Z? The previous value in the stack? No, it's not. So we add it into the stack. We get to X. Is X equal to the previous value in the stack? Yes, it is. So we pop off the stack. We remove that value. Now we move over to Z. Is Z equal to the previous value in the stack? Yes, it is. So again, we pop off the stack and move along. So we move to Y, we add Y into the stack because it's not equal to A, and then we convert this to a string and return that value. So a nice intuitive solution. The time complexity for this one is going to be O of N because we need to loop through this array exactly once. So it's going to be the length of the string. And then space is also going to be O of N because we're utilizing a stack data structure. And in worst case scenario, we have to add all of the values within the string into the stack. So there's not much to this. We create a stack data structure. We loop through the characters of string and check to see whether the last value within the stack is equal to the current character. If it is, we pop off the stack because we have found an adjacent duplicate. Else we're going to push onto the stack because we haven't found an adjacent duplicate. And then to convert an array to a string, we use stack.join and return that value. And there you go.